Hello guys, today we are going to solve the problem decoded string at index. In this problem, we are given an encoded string and we have to decode the string. And after decoding the string, we have to return the kth character. We are given an index k and we need to return the kth character. While decoding the string, we have to take care of two cases. One is this and one is this. Suppose the current character in our encoded string is a letter. Letter means if it's an alphabet, we need to write it as it is to our decoded string. And if the current character is a number or a digit, we need to repeat the string which is generated till now d minus 1 times. Suppose if we find 10 here, we need to repeat the string 9 times. 10 minus 1, 9 times. Now let's look at an example. Now let's start our example. We'll start from the left and we'll go to till the end. Initially, our character is L. Since it is alphabet, we'll write it as it is in our decodation. Then we'll move to E. Since it is also a character, we'll write it as it is. This is also a character. L-E-E. A is also a character. And when we come to this index, we see a digit, right? Now, when we see a digit D, we need to repeat the same string D minus 1 times. D minus 1 times means we have a digit 2, so we need to repeat the string 2 minus 1 times, so additional 1 time. We will repeat the same string another time. L E E E D, right? Now we move to this index. We are seeing C E. Okay. O, we'll write it as it is O. D, we'll write it as it is E. E, we'll write it as it is E. When we come here, we are seeing a digit, right? 3. So we need to repeat the entire string 3 minus 1 times. That is 2 times. Another 2 times. So let's repeat it. So after repeating, what you will need to do is they have given an k. We need to repeat the kth character. Given kth character is 10, right? So we need to return 10. 10th character means this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10th character. So we need to return O. So our answer is O. Let's look. Let's look at another example. Now let's take another example. Let's see example. O. O. Initially, the character is high. We'll copy it as it is. The character copy. Next, number is 2. So we'll repeat this one time. Which next, next we are getting a digit, right? So we'll repeat the same string another one time. That's it. Now to return the fifth one. One. This one. H. So in this way we can solve it. Solving the problem. Problem here is the decoder string is guaranteed to have less than 2.3 letters. Okay, now let's see the optimized approach, which is approach 2. In this approach 2, I will not generate the entire string. Okay, I will never go generate the entire string because of developing the entire string. I'm getting a memory exceeded error. So I will not generate it. But what I will do is I'll just calculate the length of the entire string. Initially, to break down this into steps, I will just calculate the length of the entire string, and I will click on reducing the length of string until it reaches k. Let me tell you with an example. Let's take this example. Take this example only. I will paste it here. Now what I will do is, I will not generate the entire string. I'll just calculate the length. I'll just calculate this length. Let's see how without generating the entire string, how I'm going to calculate the length of the string. Initially, this is our string, right? This is our encoded string. Now I'll initialize my length variable to 0. When I see a character, I'll just increase my length. 1 character, length becomes 2 character, length becomes 3 character, length becomes 4, and length becomes 4. Now when I see a digit, I'll just multiply it with my length. 4 2 is 8. Why are we multiplying? You see carefully, this is our string, right? So we have to repeat it 2 times. So lead plus lead, the length of it will be 8. So that's why we're multiplying it. Now when I come to C, I'll just add 1. When I come to O, I'll add 1. That's 1. When I come to D, I'll add 1. When I come to E, I will add 1. What is the length till this point? 1. When I come to the last digit, which is 3, I'll multiply this with 3. So we got the length of the string. If you see carefully, we got the length of the string, but we haven't generated the entire string. We just calculate the length. Now what you will do is, let's assume the k we need is 18. The k we need is 18, 16, 17, 18. This is the index we need, but we have n equals to 36. So there is no point in generating all these letters, right? There is no point in generating all these letters. So we need to observe another thing here. If you look here carefully, this is one string. This string is a duplicate of this. This string is a duplicate of this. So if you see, this is the original string. This is the original string, this is a duplicate, and this is the duplicate. Now what I will do is, if my k falls in any one of the duplicates, I'll take my k and keep it in my original string. If here the k is pointing to E, so I'll take my k and keep it on the same E, but on the original string. I'll keep my k on the E only, but on the original string. Then if you see carefully, we will not require these 2 duplicates, right? We will not require these 2 duplicates. These 2 duplicate lines will be, these 2 duplicate strings will be of no use. So what we'll do is, we'll discard this length. So we'll only have n equals to 12 now. So let's see how we are going to achieve this. Now here our n is 36, and we are looking to reduce the length, right? And k is 18. Our n is 36, and we are looking to reduce the length. When we have traveled from left to right, we kept on increasing our length, and now we are looking to reduce our length. So now we need to traverse from right to left. Hope you're getting my point. Yeah. Okay. Since we got the intuition, like we need to traverse from right to left, I'll start from here. And when I start from here, my length is initially 36. When I see a digit, I'll reduce my length by 36 by digit, 36 by 3, which is 12, which is same as this thing. Which is same as this thing, means 36 by 3. So I have discarded these two duplicate strings. Now if you see here, we have reduced the length of the string to 12, right? But our k is falling here, which is outside the length of the remaining string. So we need to move our k to here. We can do that using k equals to k more length of the string, the new length. The new length is 12. So this 18 more 12. Now we'll get 6, right? Just 1, 2, 3, 4, 5, 6. We have came here. So it is still pointing to the E1. This the same E which it pointed in the past. Now the length of our string is 12. And my k is here. My n is 12 and my k is at 6. Now I'm at index E. To find index E, I'll just reduce my n by 1, n minus 1, which is 11. Now my n become 11. Now I'm at D. I'll reduce again. So my n will become 10. I'm at O. And my n will become 9. I'm at C. So my n will become 8. So n has came here. And my k is here. Now if you see, observe carefully, the digit is 2. So we have to reduce our n by 2, which is a by 2 equals to, my n is 4. So n has came here, but k is at 6th index. So we have to again move k to this E, which is behind n. If you observe carefully, these two are the duplicates. So it doesn't matter if you written this E or this E. So what you will do is you'll move your k to this E by doing k equals to k mod length, which is n. K is 6, right? 6 mod n means n is now 4. So just 2. So we have came here. Now n is here and the k is here. And we came to t. When we have a character, we'll reduce the length by 1. So my n is here and the k is here. Now we are here. So when we again see a character, we'll reduce n again, and n will come here. When n reaches the k, this is the character that we want. That is the answer. Now I'm going to explain the code. Initially, I'll initialize my length variable to 0. N means the length of the string. Now I'll traverse through the string. If I find a number, I'll multiply the number with my length. But if I find a character, I'll just add 1 to my length. And after that, as I have already mentioned, I start from the back. Back of the string, and I'll go to 0, and at every index I'll reduce my for every iteration I'll reduce my length, I'll reduce my I index. Now I'm taking this character into ch. As I have already mentioned, there is like, if there is a decoded string like this and my k is here, I need to move my k from the duplicates to the original string, right? So for that, I'm doing the mod operation in order to move my k from the duplicates to the original string. Why am I adding this? Adding k equals to 0. Let me give an example. Let's take this example. Suppose s equals to this thing, and my k is equal to 6, and I'm decoding this. So when I see a, I'll add a, and when I see 2, I'll add it 1 time. When I say C3, I'll repeat this many times, right? My length is 6. In this point, we have calculated our length is length 6. Now I'll start from the ending. This is my index. I start from the ending. I take my character, which is 3. Now currently my character is 3. I'm reducing my k. I'm modding my k with the length. K is 6 mod 6 equals to 0. 0, right? When k becomes 0, and the current character is not a letter, it's a digit. When it is not if it is a character, we'll directly return that. But when it is a digit, what we need to do is we'll again go into this if condition, and I will reduce my length by 3. Now my length will become 6 by 3, which is 2. My length has become 2, right? And I again come here and I see my n is 2, and my character is this. And again my character is 2, right? Now k will become k equals to, the previous step k has become 0, right? Now 0 mod 2, so it will be again 0. So my k is 0, and the current character is also not a character. So I will come into this if condition, and again my length will be decreased by 2 by 2, which is 1. So I'll again go here, and my I will come here, and my current character is ch equals to a, and again k equals to 0 mod 1, which will be 0, and my k is 0, and my current character is a. My current character is a, so I'll come into this if condition, and I'll return the a. So that is the case we need to take care. At the end we'll return an empty string. Our code will not come until this point. We'll return the string here itself. That's it.